Hello, my dear students. Welcome to my video again, Trigonometry Equations, video number 2. From this video, I am going to continue our previous multiple choice questions from question 8. Okay, the question 8 says, what are the NPVs? What are the non-permissible values for theta? What are the non-permissible values for theta? For tan theta, cot theta. NPV stand for non-permissible values. Okay, let's rearrange this equation. Once you rearrange this equation, this will become sin theta for cosine theta, cosine theta for sin theta. That means in order to exceed these two expressions, what is the restriction? The denominators cannot be equal to 0. The denominator for first part, the denominator for the first part is cosine theta. The denominator for the second part is sin theta. This cannot be 0, this cannot be 0. That is a condition to exist any rational function. No? In case of rational function, we know q cannot be equal to 0. That is the definition of the rational function. Otherwise, if q is equal to 0, this will be undefined. Okay. Now let's say cos theta equals 0, what happened? Also when sin theta equals 0, what happened? Let's try to understand the situation using our quadrant diagram. From the knowledge of trigonometry, you know, cos theta is equal to 0 in these two positions. These are called quadrant angle, okay? In these two positions, cos value equal to 0. I just put cos equal 0, okay? Cosine value equal to 0. That is, if the terminal arm lies along positive y-axis or along negative y-axis, cosine value is 0. In the same way, sin values are 0 when the terminal arm is located on the x-axis. Okay, let's try to avoid this position. This one and this one. How to address these two positions? For sin theta equals 0, if sin theta is equal to 0, what is theta? Theta is actually multiple of phi. We can say k phi in general. K is an integer, okay? K is an integer, including 0. How do you address this one? For cosine theta equal to 0, then theta equal multiple of pi by 2. For example, if you substitute k equal 1, this is this position. If you substitute any odd value for k, those are the this position. If you substitute any even value for k, this will go to this position. That means this represent, this means this second expression, theta equal k phi by 2 represent this terminal arm, negative y direction, theta equal negative and positive y direction, theta is equal to k pi represent positive x and negative x direction. That means we have to develop a common expression for this. Common expression. Okay, what is a common expression then? If you look at the expression A, B, C, D. Okay, I am writing it here. Let's look at expression 1 under A. pi by 2 plus 2 pi k. Whatever the value you substitute for k, this does not represent both of this position. If you go to B also, that doesn't work. Let's go to C. Actually, if you go with this expression, let's look at this one. This is a representative expression. If you go with this one, this is valid for both this and this. How it works? If the k is odd number, when k is getting odd integer, this represents y-axis. If k is getting even integers, like 0, 2, 4, 5, 6 or negative 2, post negative 6, this expression represents x-axis. That means theta equal k by pi 4, theta is equal k pi by 2 represent both of these restrictions. That means if cos theta equals 0 or sin theta equals 0, those two situations represented by this equation. But non-permissible value means this cannot be equal to 0. Either cos theta equal to 0, neither cos theta equal to 0, sin theta equal to 0. That means the condition for NPV is this one. Theta not equal to k by 2. Actually, previously I tried to explain you using by considering elimination method, but we don't know to go with that. When you look at this, we understand this represents both of these situations. Okay, answer is answer number C. Answer number C. Number 9. Okay, that is pretty straightforward. Which equation is a Pythagorean identity? Okay, out of this, actually, we don't have to waste our time to writing. Out of this, straight away, the Pythagoras identity is A. 1 plus tan square theta is equal to secant square theta. We don't have to analyze other one because question is asking only one option. Which equation is a Pythagoras identity? That means option number A. Okay, let's stop that. Question number 10 also I have to discuss in the same time. That also falls into same situation. In question number 10, okay? Which equation is a reciprocal identity? Secant theta 1 upon tan theta, that is false. B, secant theta 1 upon cos theta. Yes, we can stop. That is the right answer. B, secant theta equal 1 upon tan theta. Sorry, 1 upon cos theta. So this is answer number B. I wrote this by mistake. This was tan, that's not cosine. Secant theta equal 1 upon cos theta is right answer. That is, for question number 10, answer is B. Okay, next questions. Question number 11. Which expression is equivalent to? Which expression is equivalent to cos theta upon 1 plus sin theta? They have provided a hint. Use the graphs Yes, that is also one option. But in order to use the graph, you have to check this one by one. A, B, C, D. That is a hint only. That means that is not mandatory use in the graph. Actually, if we use the algebra method, that is more easy and we can understand something. Okay, let's use the algebra method. Okay, how do we start? In this case, we can use one trick. Let's identify the conjugate of this one. What is the conjugate of the denominator? 1 minus sine theta. We know from the basic algebra, a minus b is the conjugate of a plus b. A plus b is the conjugate of a minus b. When you multiply these terms together, when you multiply these conjugate terms together, you are getting a squared minus b squared. That is the difference of 2 squared. Difference of 2 squared. That means in order to get difference of 2 squared, let's multiply. Let's multiply both top and bottom by the conjugate of the bottom. Okay, then I am multiplying. Write this as it is. Cos theta upon 1 plus sin theta. Then I will multiply bottom by 1 minus sin theta. In order not to change the value, in order not to change the expression, we must multiply top also by the same expression. Okay. Now, let's write the top part as it is. Let's write the top part as it is. What is the bottom? A plus b, a minus b. A plus b times a minus b is a squared minus b squared. That means the bottom will become 1 squared minus sin theta squared. Okay. A plus b times a minus b is going to be a squared minus b squared. A is 1, b is sin theta. This is a, this is b. This is a, this is b. That means cos theta 1 minus sin theta what is in the bottom? You can simplify this. 1 squared is 1 itself. You can write this as sin square theta. Okay, I continue from here. Write it again. Cos theta upon cos theta 1 minus sin theta. Okay, 1 minus sin square theta. From Pythagorean identity, we know that 1 minus sin square theta is equal to cos square theta. Now we can cross one cos theta term like this. Finally, you remain with 1 minus sin theta upon cosine theta. Okay, that's the answer. 1 minus sin theta upon cosine theta. That means answer number is C. Okay, let's go to our last question in this assignment. Question number 12. Express cos alpha minus sec alpha minus secant alpha divide by sec alpha plus cos squared alpha tan squared alpha times tan alpha minus sin alpha divided by tan alpha. Okay, by looking, this look like a complex problem, but that is not hard. Once you simplify, that will reduce to very simple expression. Okay, what you have been asked? Express means this everything. Express this everything in terms of cosine and sine only and simplify. Yes, we have to follow two steps. First of all, we have to write everything in cosine and sine. Then simplify. That means answer may or may not include sine alpha cos alpha. Answer doesn't say to leave with sine alpha cos alpha. Okay. Let's put equal sign and continue. Let's do one by one. Okay. Carefully look at this. I start with the bracket cos alpha. Write the cos alpha as it is. Instead of this sec alpha is the reciprocal of cos alpha. That means I would write 1 upon cos alpha. Okay, divide by, now the division line comes here. Again secant alpha, 1 upon cos alpha. Okay, that is this part, okay, this part. Plus cos squared alpha, instead of tan alpha, I would write sin alpha upon cos alpha. That is from quotient identity, okay? From the quotient identity, tan alpha is equal to sin alpha upon cos alpha. Okay, I put another bracket here. Everything is clear, no? This part will become this. This part will become this. Okay, let's write this. Sin alpha upon cos alpha minus sin alpha divided by sin alpha upon cos alpha. Actually, we don't have to struggle like this. Let's try to get the answer for the multiple choice question. As the issue, question says like this, I explain in this way, okay? Let's look at the first part. Okay, if you look at the first part, you can multiply both top and bottom by cos alpha. Okay, let's multiply this by cos alpha, this by cos alpha. Then what will happen? Cos alpha times cos alpha. Cos squared alpha. Cos alpha upon cos alpha minus 1. Divided by cos alpha upon cos alpha 1. I think everybody can understand this one, no? This is a numerator, this is a denominator. I multiplied both top and bottom by cos alpha. Keep cos alpha outside, then remove the bracket using the distributive property. Cos squared alpha, cos alpha times 1 upon cos alpha, that is 1. Here when you multiply by cos alpha divided by cos alpha will become 1. That is easy. Okay. Then what happened here? Cos squared alpha divided by cos squared alpha. That means only remains sin squared alpha. You remain with only sin squared alpha. This is sin squared alpha divided by cos squared alpha. Then you can cross out cos squared alpha in top and bottom. Then you remain with sin squared alpha. Okay, that is first part. Actually, we can ignore this one here. Times this everything. Okay, if you need, we can write this again. Here also you can multiply both top and bottom by cos alpha. That means sin alpha minus sin alpha cos alpha divided by sin alpha. Okay, what I did? I multiplied top by cos alpha. Then when you remove the bracket, you are getting sin alpha minus sin alpha cos alpha. Also, I multiplied this bottom total part by cos alpha. Cos alpha is crossed out. After that, you remove sin alpha. Okay, let's see what will happen here. Nice thing is happening here. Look at this portion. Look at this portion. Cos squared alpha plus sin squared alpha. That is 1. From Pythagorean identity, cos squared plus sin squared alpha is 1. That means, okay, let's explain this. I am gathering cos squared alpha and sin squared alpha to one place. Minus 1. Okay. Then we have to write this again. Let's put star mark here. That means we have to write this everything here. But unfortunately, we don't have to write it again. What will happen? The nice thing will happen. This is 1. Then what's the answer? 1 minus 1 times this total expression. 1 minus 1 is 0. 0 times any number. 0 times any number is 0. Okay. That means I explain this situation very slowly in order to convince in the right way. Okay. The answer is 0. Yes, there is option for 0. That means answer number is A. Answer number is A. Okay, this is the end of video number 2, trigonometric equation. Now, I have done about, I think, 12 questions from, 20 questions. 20 questions in video number 1. That is for trigonometric equations, trigonometric functions. Then another 12 questions we have discussed under trigonometric equation. I think we have discussed most of the stuff in trigonometry. Okay, I think by discussing this multiple choice question, this is a good opportunity to review all the stuffs. Okay, thank you very much. See you in the next video. In the next video, I will start some algebra part, polynomial function. Okay, see you in the next video. Thank you.